This video is just to review a couple of concepts. The first one is horizontal and vertical asymptotes, including holes. So horizontal asymptotes, just a reminder, if the degree is the same, you're going to, so if we get x of the same box over x of the same box, you're going to reduce the leading coefficients. Reduce leading coefficients. Okay, so in example, this one, the horizontal asymptote would be 1/2, right? So horizontal asymptote is y equals 1/2. Otherwise, remember the things that we talked about. If you have the number on the top is smaller or bigger than the, okay, why can't I say this? Okay, if the numbers on the bottom is big, remember we talked about having big bottom, that's when the horizontal asymptote is 0. But if the number is bigger on the top, then there's no horizontal asymptote. Okay, that's no big deal. If the number on the top is bigger than the number of the bottom, there's no asymptote. Okay. Now the vertical asymptote, I always think of it like V. V is the bottom, is where do you set the bottom equal to 0? So I'm going to take, can I even factor this one? It has a third. I probably picked a different one. Let's look down here. We're looking for vertical asymptotes and for holes. I'll use the second example. Well, one of the things you want to do is you want to see if you can factor this. So this can be changed to x over 1, x plus 1 over x plus 1, x plus 4. I can factor that. The holes happen when you can cancel something out. This is where there's a hole. So x plus 1 equals 0, x equals -1. There's a hole at x equals -1. The horizontal asymptote, however, so if I have 1 over x plus 4, I'm sorry, the vertical asymptote would be where there's no hole, and the vertical asymptote here would be -4. Now, if I wanted to know what is the actual point where the hole is, -1, where do I plug this in? I don't go plug it back into the original equation because we already discovered that doesn't work. You plug it into the factored one, so I'm going to get 1 over 3. So my hole is at -1, 1/3, and the horizontal asymptotes, again, can you reduce the coefficients? Is there a big bottom? Or if the top is bigger and there's no big 0, big bottom, if there's no asymptote. Okay, and then the vertical asymptotes, you're going to look at the denominator. Okay, another thing I want to remind you of is when you're asked to find the integral from 0 to a variable, then what you do is you take that variable and you plug it into the function, whatever that function is. Let's make it t to the third plus 1. I'm going to plug that in and it becomes x squared to the third times the derivative of what's in that box, so times 2x. So this would be 2x, x to the 6th, and I can actually simplify that one to 2x to the 7th. What is the difference between the critical points and the inflection points? Okay. Critical points versus inflection points. The critical points come from the first derivative test, and they tell you the max or the min, and that occurs when you set the derivative equal to 0. Set dy dx equal to 0, and then you'll determine if it's a max or a min. The inflection point comes from the second derivative test. I think I put it there, dx squared. Where's the second derivative test? And you set the second derivative equal to 0, and it's the inflection points. One thing I noticed in class is that C and I are alphabetical order. This comes first in the alphabet, so it's the first derivative test. This is second, it's the second derivative test. Critical points, max or min. Inflection points, is going to tell you if it's concave up or concave down. Now concave, and then really what this is telling us is since the second derivative is the derivative of the first derivative, the second derivative is kind of giving you what's happening to the slope of the first derivative. If it's increasing, it's concave up. If it's decreasing, it's concave down. Just little reminders on those things as we move forward this week.